I'll start the class in 5 minutes. Sir, I will wait 5 more minutes.
Okay.
So, welcome everyone to the live interactive session of the course Natural Gas Engineering. Today, I am going to discuss sample problems based on assignment number 2. I am the TA for this course, and my name is Ananya Mandal. So, let's start with some questions. The first question is that brine is used to measure the absolute permeability of a core plug. The rock sample is 4 centimeter long and its cross sectional area is 8 centimeters square. The brine has a viscosity of 2 centipoise and is flowing at a constant rate of 0.5 cc per second under an 8 atmospheric pressure differential. The absolute permeability is dash Darcy. So the options are A 0.0104, option B 0.0625, option C 0.1025 and option D none of the above. So, can you tell me what equation will be used here to find out the absolute permeability? What law will be used? Manoj?
Hello?
Yeah, so can you tell me what law will be used here to find out the absolute permeability?
No idea. I have not gone through with the session.
Uh, okay. So you did not see the live session, like the video session of the week 2 also?
No. No.
Okay. Okay, so whenever they ask to find out the permeability, we have to refer to the Darcy law. So, as sir taught in the class, permeability it controls the directional movement and the flow rate of the fluid in a reservoir. So, to find out the flow, we can use the Darcy law. So, Darcy law has some assumptions that it is only applicable when there is a laminar flow, no reaction between the fluid and the rock, and only a single phase is present. So, this is the equation for Darcy law, and when we replace velocity in terms of volume flow rate, we get this equation. So here in the question, they have given the brine and core specification as the length is 4 centimeter, area is 8 centimeter, the differential pressure is 8 atm, viscosity 2 centipoise, and flow rate 0.5 cc per second. So most of these terms are given and they are asking what is the absolute permeability. So absolute permeability is defined by this value K. So we have to put all the values in this equation and from that we will get the value of K. So as you can see we have used Darcy law here and putting the value of Q that is 0.5, the area that is 8, del P is 8 atm divided by the viscosity that is 2 Cp and the length as 4 centimeter. So we have to take care of the units also while calculating this. As you can see, it is also given what units has to be considered when we are solving for Darcy law. And from this we can get the value of K, which is coming out as 0.0625 Darcy. So the unit of absolute permeability is in Darcy. So from the option we can see option B is the correct option. So the absolute permeability here is 0.0625 Darcy. So whenever if any question comes on permeability, the first instance should be to consider the Darcy law. And also always take care of the units that you will be taking for solving this equation. Okay, so
In
then,
the uh,
yes.
how to find that it is a laminar flow?
Uh, so,
You have mentioned that we need to because here one thing is a laminar flow, second thing is it's a single phase present. Then we have to go by this formula, correct?
yeah, so these are the assumptions of this Darcy law that it has to be laminar flow. But when we are talking on reservoir, as sir taught that in reservoir the flow of the flow of the fluid is supposed as laminar. So that's why whenever there is a the flow around the bore well and all in radial direction, they are considered as laminar. That's why for that Darcy law is used. But even if there is not a laminar flow, there is a turbulent flow, which in reservoir case is very rare. So for that there are other equations also, but that will be discussed later. But for permeability study, we need Darcy law and we assume that the flow is laminar.
Okay. And what is actually this absolute permeability?
So it gives it is a proportionality constant. Okay, so where the proportionality between the flow rate and the pressure drop. So that proportionality is defined by the absolute permeability.
Flow rate and pressure drop in the wellhead.
Yeah, so dP by dl, so pressure drop with respect to the length, and when we equate it with the velocity or the flow rate, so the proportionality constant that we will get is defined by this permeability. Because the permeability makes sure that how the movement will be throughout the how the flow rate will act and how the movement will be because of this pressure drop. So that's where permeability term is used.
Okay.
Okay, so the next question is again another numerical, that is cylindrical sandstone core which is 8 centimeter long and 4 centimeter diameter has grain density of 3 gram per centimeter cube. If the mass of the dry core is 20 gram, the porosity of the core is. So options are A 55, option B 34, option C 23 and option D 39. So here we have to find out the porosity. So previously it was permeability, now they are talking about the porosity. So porosity is a measure of the storage capacity that is capable of holding the fluid. So permeability talks about the flow throughout the pores and porosity talks about what is the volume of the pores inside the reservoir. So porosity can be measured as the pore volume divided by the bulk volume, which is also equal to the void volume divided by the bulk volume. So here in the question it is given the length of the core as 8 centimeter, diameter as 4 centimeter, the grain density is given, that is 3 gram per centimeter cube, dry core mass 200 gram. So from these, so what we need is a pore volume and the bulk volume. So from the data that is given to us, we can find out the bulk volume, that is the length, diameter is given, so we will get the core bulk volume. Now core grain volume can be defined by the density and mass of the uh, stone of the cylindrical sandstone core. So from that we will get the core grain volume, and the pore volume will be the difference between the grain volume and the bulk volume. So grain volume means what will be the volume of single grains combined, and bulk is the overall volume. So when we will minus the volume occupied by the grains to the overall volume, we will get how much pore is left. So for so using that equation here, we can see we will find the pore volume. And now to find porosity, we need the pore volume and the bulk volume. So if we for conclusion, we are given the properties of the particles and the dimensions of the whole volume. So from the dimensions of the whole volume, we will get the bulk volume. From the properties of the particles, we will get the volume of that particle. And when we will subtract these two, we will get the how much pore volume is left. And from that, when we will divide it with the bulk volume, we will get the porosity. So here porosity we are getting as 34%, which is option B. Was that clear?
Yes.
Okay. So the next question is that the values of contact angle for complete wettability and complete non-wetting respectively are. So the options are A 180 degree, 0 degree. Option B 90 degree, 180 degree. Option C 0 degree and 90 degree, or option D 0 degree and 180 degree. So any idea what does wettability mean?
No.
Okay. So, wettability is the tendency of any fluid sticking to that of the rock. So, we are taking up the fluid out of the rock sections, right? So, if there are more than two types of fluids, so we can compare the wettability of one fluid from other, of which one will be more sticking to the rocks. So, according to that, we will understand which one will be more easier to extract out. So for that, we need to know what is the wettability of these two fluids that are on the rock. So the contact angle that will be created by this fluid on the rock will be from 0 degree to 180 degree. So 0 degree means there is complete wettability and 180 degree means complete non-wettability. That means if uh, the fluid is very much sticking to the particles, then the contact angle that it will form will be 0 degree. But if it is not at all sticking to the walls of the rock, then the contact angle it will form will be of 180 degree. So here in the question they have asked the range of wettability to non-wettability. So that will be from 0 to 180 degree. So option D is the answer. So the next question is A gas well is producing natural gas with the following composition. So the components that are present in the gas well are C1, C2, C3, CO2 and H2S. And their molecular weights are given, and also the mole fraction at which with which they are present is also given. So we have to find out what will be the specific gravity of the mixture, gas specific gravity of the mixture. So to find out the specific gravity of the mixture, first we need to find out the apparent molecular weight. Okay, so apparent molecular weight can be found out from the molecular weight of each component and the mole fraction in which these components are present. So this is the equation of finding out the apparent molecular weight. So we will multiply the mole fraction with the molecular weight of all the components and then add it up to find out the apparent molecular weight. Now to find the specific gravity, the apparent molecular weight is divided by that of the molecular weight of air. So we are assuming that air molecular weight is 28.97. So dividing the apparent molecular weight with the molecular weight of air, we will get the specific gravity that will come out as 0.64. So option B is the answer. Any doubt?
No.
Okay. So at one thing is that this is supposed to be gas specific gravity. So that word is missing. So there can be confusion because there are two. We also call when we are defining the density with respect to water. That also is called specific gravity. But here it is a gas specific gravity. That's why we are comparing the molecular weight with that of the air. So that is the difference. So it will be a gas specific gravity.
If that will be with water, then what will be the molecular? I mean, what will be the specific gravity weight formula?
Then we have to use the molecular weight for water here. When like we are dividing the apparent molecular weight divided by the rate of air here because it is a gas specific gravity. But otherwise, if we compare it with water, then it will be the molecular weight of water.
So it will be divided by what? I mean, what will be that molecular weight of water?
18.
18. So 16 plus 2.
Huh.
Okay.
So the next question is that natural gas with a specific gravity of 0.68 has pseudo critical pressure and pseudo critical pressure temperature of 658 psi and 49 degree Fahrenheit respectively. The pressure and temperature are 1550 psi, 25 degree Fahrenheit respectively. So the natural gas volume is 1000 cubic feet. So what will be the pseudo reduced pressure will be? So the options are A 2.355, option B 1.24, option C 3.032 and option D 2.55. So here they are asking about the pseudo reduced pressure. So the equation to find out pseudo reduced pressure is equal to pressure divided by the pseudo critical pressure. So it is the same thing, like if the pseudo word is not used, then whenever we are asked to find the reduced pressure, it is always pressure divided by the critical pressure. So here for pseudo reduced pressure, it is pressure divided by pseudo critical pressure. So pressure is given to us, that is 1550 psi, and pseudo-critical pressure is also known, that is 654 psi. So we will divide these two and we will find the pseudo-reduced pressure, that will be option A 2.357. Now next question is not depending on any basics, but it is a total numerical question. So it is asked that the apparent specific gravity of an equimolar mixture of two hydrocarbons is 0.794. If one of the hydrocarbons is methane, find the other one. So take the molecular weight of air, carbon and hydrogen as 28.97, 12 and 1 respectively. So it is saying that we have two hydrocarbons and the apparent specific gravity of this two hydrocarbons is 0.794. So we already know the specific gravity. Now, they are in an equimolar mixture, so half of the mixture is of one hydrocarbon and half is of the other one. It is given that one of the hydrocarbon is methane. So we know it is methane, and the other one is the one which we have to find out which hydrocarbon it is. So we have to take the molecular weight of air as 28.97, that of carbon as 12, and hydrogen as 1. So now, as the gas specific gravity is known to us, from that we can find out the apparent molecular weight. As previously we discussed that specific gravity is equal to apparent molecular weight divided by the molecular weight of the air, which is taken as 28.97. So from that, it is given that specific gravity is equal to 0.794. So we will find out the apparent molecular weight, that will come at 23. So this is the apparent molecular weight. Now, it is given that half of the molecules are of methane and half are of the unknown. So, if the total molecular weight we are getting as 23, so this 23 is equal to the mole fraction of component 1 into the molecular weight of component 1 plus mole fraction of component 2 into molecular weight of component 2. So, that is the equation for finding out the apparent molecular weight, as you can see here. Now, molecular weight of methane and the mole fraction of methane is known to us, and also the mole fraction of the other component known to us because they are equimolar mixture. So, we will equate this equation keeping the apparent molecular weight as 23, and we will find out the molecular weight of the unknown component as 30. So, from the options we can see ethane is the one which will have the molecular weight equal to 30. So, answer here is option B, ethane. So it's just you only need to know the correlation between the gas specific gravity and the apparent molecular weight and how to find out apparent molecular weight. So from that you can easily solve to find out the unknown material in the hydrocarbon mixture.
Okay.
Okay. So the next question is find the correct correlation of the gas pseudo-critical pressure for the following given conditions, that H2S is less than 3%, N2 less than 5%, and total content of inorganic compound is less than 7%. So options are A, Sutton and Standing correlation, B, Gio and Galambur correlation, and C and D are same, but the equation for the critical pressure is different for all of them. So, for this, we need to remember all the assumptions that Sir taught us when we have to study the critical properties of natural gas. The pseudo-critical properties of natural gas, for to calculate that, there are these three different correlations by Sutton, Go and Galambur and Standing. So you can see the correlations has certain assumptions. So for Sutton, the assumption is that the gases rich in heptane plus with minor amount of CO2 and N2 and no H2S. As it is already said, if there is no H2S, then only we can use this correlation. But in the question you can see it is given that H2S is less than 3%. So this correlation we won't be able to use at this condition. Next is the Gio and Galambur correlation, which is valid for N2 less than 5% and no H2S less than 3%. And the total content of inorganic compound will be less than 7%. So, this you can see is matching with the description of what asked in the question. So, this will be the correct name of the correlation. And the final one is the standing correlation, which is for natural gas without non-hydrocarbon gases, but we already have here non-hydrocarbon gases, so this correlation can also can't be used. So option B or C will be correct one, as it is saying Gu and Galambur correlation. Now we have to see the equation for the pseudocritical pressure. So the equation for pseudocritical pressure here gives 709.604 minus 58.718 gamma G. So when we will correlate, you can see option D is the correct one, which is which has the correct name of the correlation and also the correct equation for the correlation. So for solving this question, we have to remember all the correlations that are used for finding out different values for natural gas, and also how one correlation is different from other according to their validation and the assumptions that they have taken. So the next question is that we have to select the correct statement. So first option is that the formation of volume factor is defined as the ratio of gas volume at the standard condition to the gas volume at reservoir conditions. Option B is that once the gas properties are known, gas compositions can usually be estimated using established correlations. Option C, the pseudo-critical pressure and temperature can be determined for a gas of known specific gravity, even though the gas composition is not specified. And option D, that the value of gas compressibility factor reflects how much the real gas deviates from the ideal gas at standard pressure and temperature. So the we will see all these statements and find out which one is the correct statement. So the first statement they're talking about is the formation volume factor. So the formation volume factor is actually defined as the ratio of gas volume at reservoir condition to the gas volume at standard condition. So this is the definition for the formation volume factor. So we are comparing the gas volume in reservoir to the gas volume in standard condition, taking the standard conditions at the standard pressure is 14.7 psi and temperature is 520 degree Rankine. But the statement given here says that the formation volume factor defined as ratio of gas volume at standard condition to the gas volume at reservoir condition, which is inverse of what is actually the definition for formation volume factor. So this statement will not be the correct one. Next is, once the gas properties are known, gas composition can usually be estimated using established correlation, which is also not correct because as you can see when we studied all the correlation, the first thing we already knew was what was the gas composition. So according to the gas composition, we will be able to find out the apparent molecular weight, and from that we will find out the gas specific gravity. And gas specific gravity is used to find out the different gas properties. Hence, the statement here is actually the backward of what actually happens. So, we already know the gas compositions, then we can find out the gas properties. So, by using the correlation, so the second option is also not correct. Third is that the pseudo-critical pressure and temperature can be determined for a gas of known specific gravity even though the gas composition is not specified. So the pseudo-critical properties of natural gas says that if the gas composition is not known but specific gas specific gravity is given, pseudo-critical pressure and temperature can be determined from various charts or correlation developed based on the charts. So this statement is the correct one, as it is said that the if we don't know the composition, but still we know because compositions are what is required to find out the specific gravity. But if we directly know what is the specific gravity, then from that also we can find out the pseudo critical pressure temperature by using different correlations. So option C is the correct one. But let's see the option D also, that says the value of gas compressibility factor reflects how much real gas deviates from ideal gas at standard pressure and temperature. So actually the definition for gas compressibility factor is that it reflects how much the real gas deviates from ideal gas at a given pressure and temperature. So the statement varies at standard pressure and temperature or a given temperature and pressure. So here compressibility factor is compared at any given pressure and temperature, not at the standard pressure and temperature. So that term is why this statement is incorrect. Uh, was that clear?
Yes, it is a clear. Only one point.
This pseudo critical pressure and temperature. So, what will be the significance of this? I mean, what is the importance of this? Where it is used? Phenomenal.
It these are like the properties for finding out. So there are like viscosity and everything which will be required to study the flow of the fluid in the reservoir and how it will be taken out from the reservoir. So for that we need to find out the pseudo-critical pressure and temperatures, which will we can find out by certain correlations that we have studied before. So you will see there are like these terms are used to find out other properties like viscosity, compressibility. All those properties can be found out by using these uh, values. So these are like they have kept like nominal values, and from that we are getting other properties. That's why.
Okay.
So actually, Sir has defined very nicely, like how stepwise we will get each and every properties and how they're correlated with them in the like week 2 classes. So if when we will go through them, you will understand. He explained it better.
Sure. Sure.
So next question is that we have to match the following. So from the left side, we have to match the absolute porosity equation, effective porosity equation, saturation equation, and Reynolds number. So first, we will see what all these terms define, and then we will match their definition to their equation. So first thing is porosity. So porosity, there are two types of porosity, absolute porosity and effective porosity. So the when we defined about porosity, we talked about it is the pore volume divided by the bulk volume, or the void volume divided by bulk volume. So this is the same thing as absolute porosity. So absolute porosity is also equal to the total pore volume divided by the bulk volume. But effective porosity is equal to the interconnected pore volume divided by bulk volume. And effective porosity is the one which is more important for us, which will show that how one pore is connected to other one, so that the fluid will flow from that pore to the other and then can be extracted out of the reservoir. So absolute porosity can tell at what point, like what are the total pores, but effective porosity will be the one which will give us whether it is that place is eligible for us to extract out our fluid. So effective porosity talks about the interconnected pore volume divided by the bulk volume. So if we match it here, absolute porosity is total pore volume by bulk volume. So that will be option 3. And effective porosity is interconnected pore volume by bulk volume. So that will be option 4. Now saturation. So saturation is the fraction of pore volume occupied by a particular fluid based on pore volume and not by bulk volume. So saturation talks about if there is a pore and it is filled with the fluid, then how much it is filled, that will define us how much saturated that pore is. So that is equated by volume of the gas divided by the pore volume. So as we know, there can be gas, there can be like water, there can be oil. So if we are only signifying about the gas, then the saturation we will define according to how much gas is present in certain pore. So we will take the whole pore volume and compare how much volume of gas is present with respect to that whole pore volume. So that is the definition of saturation. If we find out which one we have to match, we will see option 5 is the one which says volume of gas divided by pore volume. So we found all three. Now it talks about Reynolds number. So Reynolds number we all know is the inertia force divided by viscous force, and from that you can see here how the final equation of Reynolds number is obtained. So whenever asked, the basic definition of Reynolds number is the inertial force divided by the viscous force, that is option 2. So by matching these, we can see option D is the correct one. So the last question is another numerical that says that crude oil has an angle of contact equal to 150 degree with steel. A narrow tube of radius 2 mm made of steel is dipped in a trough containing crude oil. By what amount does the crude oil rise up in the tube relative to the liquid surface outside? Surface tension and density of crude are 3 into 10 to the power minus 6 Newton per meter and 890 kg per meter cube. So options are A 2.405 into 10 to the power minus 7 meter. Option B is the same digit into 10 to the power minus 6 meter. Option C is 10 to the power minus 8 meter and option D is 10 to the power minus 5 meter. So you can see the values you will find will be the same, but the 10 to the 10 to power the value is different, which shows that here we have to very much take care of the units. So it is given that surface tension is given as 3 into 10 to the power minus 6 Newton per meter. The R value is given, which is radius 2 mm. Uh, weight is given as 89, no, density of crude is given as 890 kg per meter cube. The contact angle is 150 degree and the G value we have to take as 9.8 meter per second square. So the equation for surface tension is given as RHG density divided by 2 cos theta. From this, we have to find out what is the rise up of the crude oil in the tube. So that means we have to find out the value of H here. So the radius, the equation for surface tension needs the radius, the height, the value of G, density, and the angle of contact. So we already know the value of surface tension and all the values. So from that we can find out the height of raising of the liquid. So we will put all the values and take care of the units while putting the values and take all the units in terms of the SI unit. Like in mm, we have to take the mm in terms of meter. Kg per meter cube is fine, and all the other side units are fine. So when we will put the values, the final answer of the height will be 2.4051 into 10 to the power minus 7 meter. So that is option A. So this was normal equation we had to put the values, but here we particularly had to be very careful about the units because of unit the power of 10 will be varying. So as the value is same, the power of the 10 is the most important thing here. We have to take care of the units while calculating. Not only this one, but all the numericals that we have done, always have to take care of the units. Otherwise, answers will be wrong. These are the 10 sample questions that I had to discuss. So any doubt in these questions?
No, in assignment number two, I mean, I have not seen, but those assignment will be like this only.
Yeah, the questions
Those
are all
questions.
like not almost same, but they're almost like related to each other. Like these questions are kind like if there are the equations which are used here, maybe they are directly asked the equation, or some equations discussed here they have directly used numerical. It's like that. But the topics they have like I have touched here are the same one which been asked in the assignment.
Okay,
It's like the way the questions are asked in the assignment, the same the way I have shown in the sample questions. It's like that. Otherwise, most of
fine.
the questions in the assignment they are like directly. If you study search classes, they're like direct answers from the class, so there won't be any problem.
Okay,
Okay. And also, I think even if you don't go through the class, sir's materials are also added in the NPTEL site. So you can see the PPT that sir is teaching. In looking at the PPT also, you can find out like few of the answers you can find out, and you can refer to the PPT for studying. And if you don't understand, it is given in the PPT. This is sir has shared his PPTs also, so you can study from there. If you don't have much time, so you can go through that fast and do the assignments from there.
okay, sure.
So tomorrow is the last, like tomorrow is the deadline for submitting the assignment 1 and 2. You have to
Both?
finish. Yeah, tomorrow is the deadline
For both or only one?
for both. 1 and 2 both have to be submitted tomorrow.
Okay. Then I need to try today only to solve
Yeah,
those problems. Noted.
yeah. Tomorrow is the last day. Tomorrow by night you have to finish it and submit it.
Thank you. I thought only for the first assignment it is tomorrow, that is the 7th, and the next will be somewhere after 1 week only.
No,
Because
I
it was
checked
session
right now
started.
only because it's
Okay, no
open
issue,
here.
no issue.
Uh,
Noted.
yeah, and both of them are tomorrow. Third one is due next week on 14th. Third assignment you have to give on 14th.
Okay.
Okay then. Uh, if you have any doubts like during the assignment, you can ask. Like I can share my email. I can share my email. You can ask me any doubts if you want when you are
Mm,
doing the assignments.
yes, please.
Okay, I will mail. I have your mail ID. I will mail from my ID.
Okay. Thank you.
Okay, welcome. So next time, try to do the assignment 3 beforehand so that if you have questions in that assignment, we can discuss it in the class also.
Sure, sure. Next time I'll try.
Okay, so this class is over from my side. You can leave. I will wait for some more time if somebody joins after 7. Close the
I
class.
think today I was alone.
Yeah, last class at least two more were there, but this time nobody.
Okay.
Okay, thank
Okay.
you.
Thank you.
गेम खेली गेम खेली